For our using gradient descent in this course, we will mostly pick constant alpha, or when we get to deep learning, what we will do is we'll keep alpha constant for a while and then decrease it and then decrease it and so on, and we'll see how that works later on, but we'll mostly keep it constant. In classical optimization, sort of optimization theory that's existed for many tens of years now, there are a number of other ways of picking the step size along what's called the search direction. The negative of the gradient is the search direction, is a direction along which, or descent direction. So instead of having a fixed alpha, people, many standard algorithms use what's called a line search, where along the negative gradient direction, which is a one-dimensional sort of direction, right? It's one direction. Along that direction, you can do what's called a line search, which is you can figure out essentially what value of alpha or what step size decreases the function the most along that direction, right? So we said going along the negative gradient decreases the function a little bit, but eventually things may start increasing again. How much should you go so that you decrease the function the most? So you can do a 1D optimization, and you can do that by, say, evaluating the function for a few values of alpha, and then maybe fitting a curve and then picking the bottom of that curve, or taking a large step alpha, and then if that function value, new function value, is higher than the old function value, decrease alpha by a half, and then another half until you decrease the function value or something. So then you would be kind of picking the alpha value that roughly decreases the function the most, okay, up to sort of an order of magnitude. Anyway, so that's sort of line search or variance or approximate line search. You can either do a very exact line search, exact optimization along that direction, or just a very rough thing where you decrease alpha from a large alpha until you decrease the function. There are conditions, one called the Armijo-Wolff condition, or Armijo condition and Wolff conditions, that ensure that if satisfied, the gradient descent will or the optimization will converge. These are conditions on how much to reduce f by to ensure convergence, I guess, or good convergence of the optimization algorithm. So we won't really talk about these things in greater detail, I guess. If you're interested in sort of these subtleties of optimization algorithms, you should take a whole course on, say, nonlinear optimization, and there may be courses at Ohio State on that.